Hello everyone. So here in this video, I'm going to show you how to solve confidence interval problems. All right, so we'll start with this one, number one. How much do Americans sleep each night? Based on a random sample of n equal to 1120 or 1,120 Americans, 15 years of age or older, the mean amount of sleep per night is sample mean M equal to 8.17 hours according to the American Time Use Survey conducted by the BLS or Bureau of Labor Statistics. Assuming the population standard deviation for amount of sleep per night is sigma equal to 1.2 hours, construct and interpret a 95% confidence interval for the mean amount of sleep per night of Americans 15 years of age or older. All right, so you'll notice I've highlighted some things in this problem. So the reason why I highlight, or maybe if you're looking at a problem, you can highlight it or you can circle it or whatever it is, but these are the important things that you need to take out of the problem, right? So we have a sample size, n equal to 1,120 Americans. We have a sample mean, m equal to 8.17 hours, and we have a sigma, population standard deviation, equal to 1.2 hours. Now we're being asked to construct a 95% confidence interval. So here, right here, is the confidence interval formula, right? CI for short, equal to sample mean plus or minus z critical value times sigma divided by the square root of n. Remember that z critical times standard error, right? Standard error is equal to sigma divided by the square root of n, right? Is equal to our margin of error. So it's the sample mean plus or minus a margin of error, which is this part of the formula, all right? So let's go ahead and plug in the numbers. We have everything we need to actually construct this 95% confidence interval. So here is the next part, right? So 95% confidence interval is equal to plugging in the numbers, 8.17 plus or minus, and the z critical for 95% confidence interval is 1.96, and that's something that with time you're going to remember or you're going to memorize, you're going to have it in your head. So 1.96 times sigma, which is 1.2, divided by n, or the square root of n, which is 1,120. And so the next step is to simplify this, or at least take the square root out, right? So 8.17 plus or minus 1.96 times 1.2 divided by 33.4664. Okay, so far so good? Hopefully, right? And then we simplify the fraction because we don't like to deal with fractions, or at least I don't. 8.17 plus or minus 1.96 times 0.0359, which is equal to 8.17 plus or minus 0.07. Now at this point I've rounded up because it's just easier to do the addition and subtraction. So I start with subtracting 0.07 from 8.17, gives me 8.10, and then I add them together and I get 8.24. So our 95% confidence interval, this is how it looks like, right? So it's 95% CI bracket 8.110 comma 8.24 end bracket, right? And there's our first confidence interval example. Now, the interpretation, the question asks to interpret. Don't forget this part of it, right? So the interpretation, here we go. We are 95% confident that the mean amount of sleep of Americans 15 years of age or older is between 8.10 and 8.24 hours per night. All right, let's do a second one. A school social worker wishes to estimate the mean amount of time each week that high school students spend with friends. They obtain a random sample of n equal to 1,175 high school students and finds that the mean weekly time spent with friends is sample mean M equal to 9.2 hours. Assuming the population standard deviation amount of time spent with friends is sigma equal to 6.7 hours, construct and interpret a 90% confidence interval for the mean time spent with friends each week. And let me go ahead and highlight the 90% because that is what we're trying to find, right? To construct a 90% confidence interval in this case, right? So notice I go ahead and pull out the numbers again. N is equal to 1,175, M is equal to 9.2 hours, and sigma is equal to 6.7 hours, right? The confidence interval, we've already talked about it, right? CI is equal to sample mean plus or minus a margin of error, which is Z critical times the standard error, which is sigma divided by the square root of N. All right, so let's plug in the numbers. Whoops, this is supposed to be a 90%. There we go. 90% confidence interval is equal to 9.2 plus or minus 1.65. And 1.65 is the confidence level, or is the Z critical value for a confidence level of 90%. Okay? So 1.65 times sigma, which is 6.7, divided by square root of N, which is 1,175. So that's equal to 9.2 plus or minus 1.65 times 6.7 divided by 34.2783. Let me change that again. Okay. Which is equal to 9.2 plus or minus 1.65 times 0.1955, which is equal to 9.2 plus or minus 0.32, which gives us, if we subtract 0.32 from 9.2, we get 8.88, and if we add the two together, we get 9.52. So our 90% confidence interval is, open bracket, 8.88, comma, 9.52, close your bracket. The interpretation, here we go. We are 90% confident that the mean amount of time that high school students spend with friends is between 8.88 and 9.52 hours each week. All right, so here's one last problem. This one has data values, and we have to find the descriptive statistics. And so the reason I want to show you this problem is so that I could show you how to find descriptive statistics in Excel or using Excel. All right, so let's do this. So number 3, a researcher for the FAA wants to estimate the average flight time in minutes from Albuquerque, New Mexico to Dallas, Texas for flights with American Airlines. They randomly select 9 flights between the 2 cities and obtain the data shown. Assume that this variable is normally distributed with a population standard deviation, sigma, equal to 8 minutes. So here are the data values. There's 9 of them. So N is equal to 9. So 91, 95, 99, 100, 103, 106, 109, 111, and 117. And this is in minutes, right? So let me go ahead and bring over the Excel worksheet really quick, right? So I've gone ahead and entered the data values, right? So in column A here, I've gone ahead and entered all 9 of the values, and I've labeled my column, of course. And so what I want to do is I want to go ahead and show you how to calculate sum, mean, or the sample mean, the sample variance, and the sample standard deviation. All right, so let's start with sum so that you can show your work when you're doing your descriptive statistics, right? So this is equal. Always, whenever we do equations in Excel, we always start with the equal sign. Equals sum, right? That's what we're looking for. And then we go ahead and let me escape real quick. Let me start over. Equal sum, open parentheses, and then highlight my values, close parentheses. Don't forget to close the parentheses. And there's our sum. Sum is equal to 931. Okay. So let's see if we can figure out the mean. So equal, and the mean in Excel is average. And open parentheses. And it doesn't matter if you start from the top or the bottom. Just make sure you highlight the 9 data values. Close parentheses. And there it is. There's our sample mean is 103.44. So let's do variance. VAR, open, so equal, VAR, open parentheses, highlight the 9 values, close parentheses, hit enter. Our sample variance is 67.028. And the standard deviation is equal ST DEV, open parentheses, highlight the 9 values, close parentheses, hit enter, and there we go. It's 8.187 or 8.2, and notice how close our sample standard deviation is to the population standard deviation of 8 minutes, right? So I wanted to show you this really quickly so that you can do the descriptive statistics in Excel, all right? So let's take a look at A. It wants us to use the data to calculate a point estimate for the population mean flight time between Albuquerque and Dallas on an American Airlines flight. So we calculated, let me go back into my, whoops, sorry about that, went too far. All right. So we already calculated, if you remember, the sum was 931, so we divide by 9, and our mean is equal to 103.4. And I went ahead and rounded to 1 decimal place because we're going to just add and subtract the margin of error from this number, right? All right. So B is asking us to construct and interpret a 95% confidence interval for the flight time. So remember the confidence interval formula, right? CI is equal to sample mean plus or minus the margin of error, which is Z critical times standard error, which is sigma divided by the square root of n, right? So all we need to do is plug in some numbers, right? So 95% confidence interval is equal to 103.4 plus or minus, remember 1.96 was the Z critical value for a 95% confidence level, times 8 divided by the square root of 9 gives us 103.4 plus or minus 1.96 times 8 divided by 3, which gives us 103.4 plus or minus 1.96 times 2.667, which gives us 103.4 plus or minus 5.2. And now I get to subtract and then add these two values. So I always subtract first because that gives us the lower bound of the range or the interval, right? So 103.4 minus 5.2 gives us 98.2. And when we add the two numbers, we get 108.6. So there's our confidence interval. This is how we write it out. So 95% confidence interval, open bracket, 98.2, comma, space 108.6, close the bracket. The interpretation? We are 95% confident that the mean flight time from Albuquerque to Dallas on an American Airlines flight is between 98.2 and 108.6 minutes. All right, one more. And the reason I'm doing this is so that you can see what happens to the interval when we increase the confidence level. All right, so here I'm asking you to construct and interpret a 99% confidence interval for the flight time, right? So in B, we did a 95% confidence interval. Now we're going to do a 99% confidence interval. So we've gone from 95 to 95, from 95 to 99. We've increased our confidence level. All right, so what happens to the interval? But first, let's calculate this out, right? So the 99% confidence interval, now the numbers stay the same except for Z critical, right? Z critical for a 99% confidence level is 2.58, okay? So the numbers, so here's our formula. 103.4 plus or minus 2.58 times 8 divided by the square root of 9 everything stays the same except for the 2.58, right? 103.4 plus or minus 2.58 times 8 divided by 3. 103.4 plus or minus 2.58 times 2.667, which is equal to 103.4 plus or minus 6.9, right? So I always do the lower bound first, so subtract the two numbers first. We get 96.5, and then we add the 2 for the upper bound, and it gives us 110.3. So our 99% confidence interval is 96.5 to 110.3. The interpretation, we are 99% confident that the mean flight time from Albuquerque to Dallas on an American Airlines flight is between 96.5 and 110.3 minutes. Now, what happened to the width of the interval when the level of confidence increased? Well, the confidence interval got wider. The range of 96.5 to 110.3 is wider than 98.2 to 108.6.